Okay, so picture this. You're running a massive online service, something like a popular game or a huge e-commerce site. Now imagine needing to move that entire live operation from one cloud provider, say Amazon, over to another one, like Google. This has been one of the biggest, most frustrating unsolved problems in cloud computing for years. But what if I told you a new framework might have just cracked the code?
Just let that sink in for a moment. Your favorite app, your go-to website, with millions of people using it right now, could be physically moved from one data center to a completely different one, running on totally different infrastructure, and you, the user, would have absolutely no idea it even happened. That's the dream, right? That's the holy grail of cloud flexibility, and it's the exact problem a new system called FlexiMigrate is built to solve. So, you might be wondering, why is this so hard in the first place? Well, the modern internet is built on this amazing technology called containers. They're like these perfect, standardized shipping boxes for software, and they promise that you can run your code anywhere. But here's the catch. The giant cloud platforms that actually manage all those containers, they've kind of become like walled gardens.
And here's the real rub. Even if your app is perfectly packaged up in a container, the big management systems, you've probably heard of them, like Kubernetes, Docker Swarm, or OpenShift, they all play by their own set of rules. They have their own unique ways of doing things. Trying to move a running app between them is like trying to plug an American appliance into a European socket. It just won't fit. And in the world of cloud computing, this creates a massive problem we call vendor lock-in.
Now, this isn't just one single problem. Oh no. It's more like a collection of massive technical headaches all happening at once. The research behind FlexiMigrate does a great job of breaking it down into 5 huge roadblocks that have, until now, made this dream of seamless cloud migration pretty much impossible.
All right, let's run through these. First, you've got dependency and heterogeneity. That's just a fancy way of saying your app is built for one system and you can't just drop it into another. Third, state transfer. That's a big one. Think about moving all the live data, all the memory of a running app. It's incredibly slow and expensive. Fourth, network disruptions. You move your app, its address changes, and boom, your users get an error page. And finally, number 5, the systems we have now are, well, they're kind of dumb. They don't know the best time or the best place to move to.
And don't just take my word for it. This quote from the research paper really hits the nail on the head. It says current methods use static policies. In other words, they're just following a simple, unchanging script. They can't adapt to what's happening in the real world. And that means you're wasting money, you're wasting computing power, and your users are getting a worse experience. The takeaway? We don't just need a way to move stuff. We need an intelligent way to do it.
And that is where FlexiMigrate comes into the picture. This isn't just a small improvement. It's a complete rethink of the entire problem, and it's built on 4 brilliant innovations that all work together to create what's basically a universal translator and a super smart moving company for the cloud.
The first big idea is just genius in its simplicity. It's a container in a container. The easiest way to think about it is like a special moving box. You put your application, your stuff, inside this parent container. Now this outer box is special. It's designed to work with any moving truck, any cloud platform. It protects what's inside and handles all the weird specific details, making your app totally independent.
Next up, how does it tackle that massive data transfer problem? Well, instead of copying the entire application state every single time, which could be gigabytes and gigabytes of data, it does something much smarter. It uses a delta-based approach. It sends a full copy just once, and after that, it only sends the tiny little changes, the deltas, that have happened since. This makes the whole process ridiculously faster and uses way less network bandwidth.
Okay, but what about those annoying network problems that knock your service offline? FlexiMigrate solves this using something called software-defined networking. You can just think of it as a super smart, all-knowing traffic cop for the internet. The split second your application moves, this SDN traffic cop instantly tells all the incoming traffic, hey, don't go there anymore, the party's over here now, and it reroutes everything seamlessly. The user never sees a loading spinner, never gets an error, it just works.
And finally, the fourth piece of the puzzle, the AI-powered brain of the whole operation. FlexiMigrate uses machine learning to constantly analyze everything in real time, server loads, network traffic, costs, you name it. It then predicts the absolute perfect moment and the ideal new home to move the application to. It takes all the guesswork out of the equation and makes the smartest move every single time.
So the theory sounds absolutely incredible, right? 4 big innovations tackling 4 huge problems. But the real question is, does it actually work in the real world? Well, the researchers put it to the test, and the results are pretty staggering.
First up, the big one for any online business: downtime. That's the amount of time your service is completely offline during the move. FlexiMigrate cut that time by nearly 79%. I mean, wow. For any company that relies on being online, reducing your unavailability by almost 80% is an absolute game changer.
Next, how fast is it? They measured the total time it takes for the whole move to happen, start to finish. FlexiMigrate was 46.2% faster. We're talking about a process that might have taken 15 seconds, now happening in under 8. That speed is crucial when you need to react instantly to problems.
And remember that clever delta-based data transfer we talked about? It had a massive impact. It resulted in a 50% reduction in network overhead. It literally uses half the bandwidth. That makes these kinds of moves possible even when your network is slow or expensive.
And finally, the process isn't just faster, it's also gentler on the system. It required 27.1% less CPU power to get the job done. Now that's really important, because it means the computers can stay focused on serving your users instead of getting bogged down by a move happening in the background.
So what really sets FlexiMigrate apart from everything else out there? It's the fact that it brings everything together into one package. As you can see on this chart, other approaches might solve one piece of the puzzle. Maybe they use machine learning or they have some networking smarts, but they're still stuck in those walled gardens. FlexiMigrate is the first to check all the boxes. It's platform independent, it manages the network dynamically, and it uses AI to make smart decisions.
So what's the big picture here? Why does this matter to those of us who aren't running massive data centers? Well, a technology like this points to a future of what you might call fluid computing, where our digital services are no longer stuck in one place.
I mean, think about what this world looks like. Companies are no longer locked into a single cloud provider. They can just move their apps to wherever is cheapest or fastest at any given moment. You can build these ultra-resilient systems that automatically move an application away from a server before it even fails. And it totally unlocks the future of edge computing, letting jobs move seamlessly between a huge central cloud and the small devices in our hands.
And it really leaves us with this one final massive question. For decades, the internet has been built on this idea of fixed places and static addresses. But if our digital services are no longer tied to one physical spot, if they can move and adapt and even heal themselves intelligently and instantly, what does that actually mean for the fundamental architecture of the internet? It really points to a future that could be far more dynamic, more resilient, and a whole lot smarter than anything we have today.